just gathered together, and I hope you hear me well. You see us also well. Glad that you joined our webinar dedicated to 3D scanning with color, digitalization, documentation, and virtual research. This is the series of the webinars related to, we can say, non-technical applications like archaeology, museology, anthropology. Today we would like to show you some of our workflows, some of our possibilities in those sectors, what we can do, and also what we've done during this time of our development. So let me start with a little bit introduction of our company, of our history. I guess some of you already know me. My name is Piotr. I'm export channel manager in Asia Pacific, and today I will be hosting this webinar together with my colleague. So Mr. Peter Wieczorek, our technical support manager, and also Natalia Skornicka, she's a product manager in archaeology. Today together we'll share some information with you related to this topic. So let me continue. All right, so at the very beginning, our short company introduction. As you might know, we are a Polish manufacturer of contactless 3D optical scanners, already more than 20 years on the market. In 2020, we've been celebrating our 20th anniversary. Unfortunately, due to COVID-19, we couldn't celebrate it together. We could only celebrate it virtually, also via camera, like webinar, but we hope that situation will be just only better and better in future, and finally we'll have a chance to meet face to face in real. Speaking about our technology, we are mainly focusing on 3D data obtained by structural light measurement technology, also white LED, which allows us to receive reliable information about the color of the texture. And what is very important for us is the metrologically verified accuracy, which means that we can prove our accuracy and we can repeat this process for digitalization or visualization or archiving, which is very important. During our development, we had a chance to cooperate with universities, with institutions all over the world and Poland, and we think that this is a great way to get to the students, to the younger generation, and teach them how to operate with our technology, how to use 3D scanners in their researches, and we think that we can, by this, we can promote also our technology. Second thing, worldwide distribution. We are cooperating with distributors from all over the world, from Asia, from Europe, from America. We want to develop, we want to create more channels in the future. And of course, we are constantly improving our technology. We're launching new devices, new software functions, functionalities that you saw at the end of 2020. And for example, today we would like to also reveal our new product, our new scanner, and you will have a chance to see the performance during the live demo. And I think that's going to be interesting. Okay, let's move forward. Some of our customers in the museology and archaeology, not all of them, but these are the clients that we work with, and a lot of museums in Poland, they are already decided to choose our technology to scan artifacts, to scan exhibits, provide virtual museums, virtual tours. During our development, we've done a lot of such projects, and during the COVID, during the pandemic, we think that this even increased because people are getting more aware about the necessity of using 3D scanners in their researches, in digitalization, to even share the exhibits, virtuality, because this is not possible to meet other people in real life because we have a pandemic, we have limitations in travels. So I think this is a great way to show the exhibits and also provide
reliable researchers, virtual researchers. This is why today we wanted to gather together and discuss it. As you might see here, some of the also work by museums like National Museum of Prehistory from Taiwan. Very good customer. I've met with them in Taiwan, so a great workflow what they are doing. I really appreciate that, and other facilities. This is always a great experience to work with such a professional people. Okay, let's continue. A brief company history. So as I mentioned at the beginning, 2000 our foundation. In 2005 we received the first award, Polish Product of the Future. In 2013 we start distribution all over the world, which means we also start to appear in worldwide exhibitions like TCT Japan, TCT Asia. We also appearing on conferences. So during that time we a little bit boost our visibility on the market. In 2015, we launched a new product line, which is a MICRON3D. In 2019, we launched a MICRON3D Stereo scanner dedicated to industrial application. And finally, 2021, today, the official premiere of MICRON3D Color 18 megapixel dedicated to archaeology, museology, anthropology, and we can say non-technical applications. Okay, let's move forward. The board of our directors. So our managing director, Anna Gębarska, company founder, 20 years ago, she established SMARTTECH 3D. Our CEO, Chris Gębarski, experienced metrologist. He's also maintaining all the channels and in Asia and Europe and Americas. And Professor Małgorzata Kujawińska, our technology advisor. She's an author of more than 400 scientific papers. And we can improve our technology because of also of their workflow and which is referred to optical metrology, interferometry. This is very important for us, and we can also right now increase our technology enhanced with the new solutions, new functionalities. Okay, let's move forward. Our international team. I mentioned that at the very beginning, we've been celebrating 20th anniversary. We couldn't met with all of you. We planned it, but still the traveling is it's limited. So that's why we hope, I don't know, maybe in 2021 we'll be able to organize it. But this is the photo from one of such a meetings with our distributors a few years ago. We hope that this will be possible to organize again. And see you face to face in real life, not virtually. What make us unique? So first of all, high resolution. As you probably know, we have a 24 megapixel scanners with white LED, which allows us to obtain a realistic color of the texture. This is the highest resolution on the market, and we believe that using such device we can be very efficient. We can work very efficiently in the field of archaeology. The second thing is that our own software, SMARTTECH 3D Measure, which can handle huge amount of data, and we can provide precise analysis of the artifacts. And this is another thing which is very important. I mentioned scanning with a texture, so we got a color point cloud with a lot of points visible. So a high density point cloud for us, it's also very important. And the last thing is the metrologically verified accuracy, which guarantees the repeatability of the scanning results. So we can repeat our digitalization. We have the same results. There is no impacts on any other influences. This is another thing which is very important. The work by distribution, we work with our channel partners, our business partners in United States, in South Americas. We work with those partners in Europe, in Asia. We are also looking for distributors specializing in the field of archaeology that have some connections with people specializing in that field, with museums. As you might know, we've been cooperating with many of such museums or institutions, and we want to develop, we want to continue this path. Okay, let me switch the voice to Natalia, and she will explain more details related to important things about archaeology.
Thank you very much. Hello, everyone again. As it was said, I am archaeologist. I work in the field since few years. Right now, besides being an archaeologist, I am also offering my knowledge here in SMARTTECH 3D company to help improve the scanners to be able to work with artifacts in the archaeological field, in museology and conservatory as well. I think that first of all we should cover some basic terms. We will be using them a lot during presentation, and I actually, while talking about 3D scanning, those are most frequent ones that we can meet. So what is digitalization? Digitalization is transforming an object, a real object, into its digital version, which, while using a specific software, we are able to use to make some advanced measurements, really exact ones. We are able to create a reconstruction. We are able to make some scientific research on it. Archiving is a digital record with accuracy, with such high accuracy that we are able to make an identical model of the object that was archived. It is especially important while working in museology because, for example, if we have some artifact and it will be damaged or destroyed, it is really important to have some records how the object looked like before. Also, while conservating process, when it's really invasive, we are able to check how the object looked like before. So those are really important elements of working as a museologist. The last term is visualization. Visualization is achieving an image that contains basic features of an object. It means its shape, its color, but you cannot make any measures based on this image because the accuracy is too low. But because of it, because there's not high accuracy, the size of document file is much smaller than from, for example, archiving data. So it's easier to use it during presentation, actually during any kind of project when this kind of accuracy, where measurements are not important, but the shape of some artifact is important. Now, when we have covered the essentials, I would like to give the floor to our technical support manager, and he will tell you more about technical aspect of a 3D scanning process, and then we will be going to some examples to understand easier what we can take, how we can use a 3D scanning process for.
Okay, hello everyone one more time, and we will start from the thing, what is the 3D scan? 3D scan is a tool which gives you a lot of possibilities. The 3D scan is non-contact measurement, which gives you the information not only about the shape of the object, but it gives you the real color reproduction captured in the same time when you are capturing the geometry. So why we are scanning? So it gives us a possibility to capture high resolution and high accuracy data in the really short time. It starts from 4 seconds of the single scan. In this time, you are able to capture millions of points from our real object. What more? We can use the data from the scanning. So we can create the virtual museums. We can create the virtual passport of the artifacts. We can do the reverse archiving. You can also make the 3D copy. Nowadays, more and more 3D printing companies have the 3D printers in color. So it's also worth to think about this. Also, it gives us the time saving. So how we exactly do it? At first, we need to have the object which we want to measure. After that, we do the measurement, usually using the turntable to automate the process. And as a raw data, we get the point cloud, which can be converted to the triangle mesh with a real color reproduction. Advantages of the 3D scanning. First, as I told, is the high accuracy and high resolution. The accuracy starts from 7 microns, so it's really high. The second is it's time saving because in most of the object, to scan the full shape of the object, you need from 15 minutes maybe to 40 minutes to get the triangle mesh with the texture. Also, you can do the virtual research in few units worldwide in the same time without having the exact artifact. You just use the virtual twin. Also, the scanners are really easy to use. I was on the some implementation in the museums, and there is no problem to learn how to use it and how to post-process the data in 1 or 2 days. And the quality is really important because with our scanner, you have a really good resolution. So you see the really small details. You see the everything like you will have the same object in the hand. In our software, you can make the automations. So with just one button, you can do the measurement, the post-processing, and the creation of the mesh. The second advantage is that you can make some dimensioning, you can make the cross sections, you can check the area and the volume of the object. You can make some virtual passports. So what I mean is that you can scan the artifact before the exhibition or before the conservation and after, and see if it damaged, how it changed, or anything you want. You have always the data from before exhibition. So if something will be destroyed and it will be needed to check how it was looking or something like that, you can just back to this data to compare it. And I need to mention something about from the parameters of 3D scanning. So we have two main parameters, the accuracy and the resolution. So as you see on these two photos, the accuracy is the same because the accuracy means the error of the position of the point on the real object and on the object on the virtual representation. But as you see, this object, this left and right photo don't look the same. So on the left photo, we use the detector with the 2 megapixels. And on the right one, we use our newest scanner, 18 megapixel resolution. So as you see on the small object is really important to have the high accuracy to see how the object looks like. So not only accuracy is very important, but even more important is the resolution of our scanning. Okay, so let's see some of our scanner, and Peter will also introduce you with newest scanner, Micron 3D color 18 megapixels.
Okay, so as you can see on the screen, we can divide our 3D scanners into industrial and technical application and non-technical applications like archaeology, like 3D printing, museology, anthropology. This is what I would like to concentrate today. So I would like to show you our new scanner, which is a Micron 3D Color 18 megapixel. As you might see here on this photo, this is a Micron 3D Color line. What does it mean? It has a full carbon fiber housing, which is sealed, and we have replaceable dustproof HEPA filters, which prevent the system that can work in difficult conditions. It's resistant for any kind of dust that might appear, and also due to the carbon fiber housing, we can work in like a stable environment, so no like I don't know, like the changing temperature doesn't have any impact on this system. Applications, the possible applications, mainly archaeology, digitalization with color, also 3D printing with color, which become more popular right now. We can provide 3D copies of the artifacts very easily and smoothly. So we can say that dedicated sectors are archaeology, museology, and anthropology. Of course, any other possible application like design would be also possible. Yes, because the color acquisition is also very important in this field. We are incorporating white LED structure like measurement. What does it mean? We can scan with a color. We received as a default a color point cloud, and we can create a triangle mesh with color. This allows us to automatically show the data with a color, which is very important for scanning and digitalizing artifacts, and then provide a triangle mesh, which is going to be a copy, precise copy of the artifact. That's why this is crucial. It's a must once we are speaking about the digitalization in the field of archaeology and museology. The accuracy is also very high. It starts from around 15 microns. So our process of scanning could be repeat with a 15 micron accuracy once we are having a scanner with small field of view like 8460 millimeters, which is dedicated to small objects like coins, like insects, like small bones. Everything is possible to acquire. And resolution, it's 18 megapixel. This is another system. We can say it's a little bit between 10 and 24 megapixel in our offer right now. What is the main advantage is that we have exchangeable lens. We can have one scanner with two field of views. So you don't have to purchase another system once you're gonna scan a little bit bigger artifacts. You can have one system dedicated to smaller artifacts and bigger artifacts. This is a big advantage. And the second advantage is the speed. This scanner, it's relatively fast. You can finish your single scan in around 4 seconds and around 8 seconds to receive a data on the computer that will appear on the screen. So once you're scanning a lot of artifacts and you want to make it efficiently, this scanner will stand this, and you can also set up the automation as Peter mentioned. So you can set up the automation with few sequences like scanning, post-processing, creating triangle mesh, obtaining the color, and you can just obtain it by just one click of the button. It's very easy, it's very efficient. So this is what we recommend for archaeologists to boost their workshops when they are working with a lot of data, a lot of artifacts. Okay, and as a package, we are giving a SMARTTECH 3D Measure software, which is a heart of our system, which allows us to obtain the data, to provide reliable measurements, post-processing, dimensional analysis, also 3D Compare, which is a new functionality that appears in a version software from 2020. The software is very efficient. You can work with millions of data with a good gaming PC, laptop PC. As for example, right now we are using a laptop. We also have advanced functionalities. I mentioned dimensional analysis, like we can scan the object, we can check the area, we can check dimensions, which using the standard manual methods are, I will say, complicated or not precise, because here we can scan with around 50 micron accuracy using caliper. I don't know, we might have 1 millimeter accuracy. This is not precise. This is not what we are doing in our system. And also, I mentioned one click of the button. So using our system, using our software, you mainly just click one button to proceed to another sequence, to another process, like 3D scanning. So it's just one click of the button. Then obtaining triangle mesh is just one click of the button. Exporting the data is also one click of the button. So using the software is very easy. You don't have to be engineer. Like I'm archaeologist, also Natalia's archaeologist. We can easily operate with the software, with the scanner, and we don't have problems with it. So that's very important. So the archaeologists, museologists then can smoothly work with the system.
We get to the point when I will be presenting some of the examples of using 3D scanner technology in archaeology and museology. As I told before, I'm still working as an archaeologist, and uh, since I contacted this technology, I was amazed that how much you can do with it, how useful it can be in our work. Unfortunately, still up till today, this technology is not widely used in museology and archaeology, but I hope it will change. It is really easy to use, and I can tell because I'm not an engineer in any means, and it's really easy for me too. And the possibilities are endless and can make our work much faster, much more efficient. It's just great, incredible. So the first example, when we are thinking about 3D scanning and 3D technology, to use it in museums, the first thing that comes in mind is popularization and education. And perfect example of this will be the project in National Museum of Prehistory in Taiwan. They use 3 of our scanners, and they have huge collection of artifacts from Taiwan culture. I believe it's the biggest one in the region. Of course, beside the advantage of making archive data of all the collection, they are also doing a lot for educational purposes. They are organizing online exhibitions, lectures. I believe they also organize an annual workshops for people, especially young people who are interested in how this technology works, how you can use it, and of course they are getting more familiar with the cultural heritage of their region as well at the same time. Of course, this year it was not happening because of coronavirus, but usually they are organized those workshops. Here in Poland, in my country, there are also popular projects to make some use of 3D scanners for popularization and educational purposes. Here you can see examples from 2 museums, a museum in Kalisz and museum in Gniezno. On the pictures you can see the pictures from the website, from the online catalog that is available for everyone who wants to see it. Those museums collections are from the early medieval, actually from medieval, but those you can see are early medieval ages. So they are connected with the beginnings of Polish culture, of Polish nation. So it's really interesting and important for us in here as well. On the pictures you can see, for example, the one-handed sword from 10th, 12th century, ceramic rattle, or the comb from the 11th century as well. You can rotate all of those artifacts. You can see it up close. If you would have access to the basic data, you would be able to make some measurements as well. So by having access to such a virtual exhibition, virtual collection, it makes really easy for archaeologists to work. Even if you just love history and want to see it, now when we cannot travel around, you can just go online and see all of that. You can see it closer, you can rotate it, so it's not like, it's even sometimes better than in real museum when you can see some artifacts just from some distance. You cannot come closer, depends on the artifact. When you are a scientist and you have to write any kind of paper, you know that sometimes, especially in the archaeology field, it's not that easy, because some artifacts are like all over the world in the museums in different countries. So it's harder for us to make a complete paper. If such exhibitions and collections would be more popular to make online, it would be much easier to make great papers as well. Here you can see some pictures also from museum in Kalisz, but we decided to show it separately because of the importance of this particular artifact. This one is the denary from the Bolesław the Brave ages. So, and it's one of 3 known in our country. It's really rare. It was found, one of them was found in a treasure that was dated in the end of 10th century, so the data of those coins could be the end of 10th century or the beginning of 11th century. Because it's so rare, it's also because of the data of producing this particular coin. It is said that these coins were probably one of the first or the first denarii from Bolesław the Brave, and we have only 3 up till today. So it's harder to get access to it, to see it, if you were interested if the history of coins. And because it's so rare, it's really often shown during presentations, during lectures. We made 3D scanned model of this coin. So it is possible to show during presentation the 3D model. Also, we use the scan to produce a sample to actually produce the copy of this coin. So besides being able to show on the screen the model, we are also able to produce a copy that you can physically take with you and show someone. You can produce it and send it to another museum to show on the exhibition. And of course, you have archived data of this coin. An example of making a copy based on 3D scan this cannon from Malbork Castle Museum. Actually, the story is kind of interesting. During the visiting of the museum of the castle, one of the visitors noticed that this cannon was not found in this particular museum, but in the castle nearby. So the story about all this battle around the cannon and around those castles was reviewed, and it was living for a little stronger. It was decided to make a copy, first of all to make a 3D scan of this cannon for people who are interested in such kinds of artifacts. They will know it's really interesting one as itself, but also the history was a little bit vivid also. Based on the scan, it was decided to make a copy and bring it back to the original castle where it was found. Also, there was a project to make an alteration on this model that was scanned and actually make this cannon work. So it is another interesting fact that you can, based on the model that you have from 3D scanning, make something, say something different. For example, bring something that is destroyed back to life, back where it was at the beginning. When we are talking about making archaeologists' life easier with making collection more accessible, here is the perfect example, not from archaeology, but from anthropology. The University of Łódź, they has huge collection of human remains, around 3,000 skeletons from one area. It's called Brześć Kujawski. It's really interesting one because of the settlement continuity from approximately 11th century to 19th century. Being able to work with remains, human remains from such periods of time opens a lot of doors to research, a lot of research. While making this a particular project, scientists wanted to check how human physics changed during this time, during those centuries. Up till now, 200 skulls were scanned, and they are they were making some DNA tests, so the base is that much bigger. It's accessible online. You can check it, you can rotate every skull, you can compare one to another. You can also make like digital cross sections, as you can see on the first picture on the left. For us, it's important to make any kind of comparison, actually any kind of research. And it's even if you have physical access, if you can drive to Łódź or fly to Poland and drive to Łódź and check those collections, making a drawing of a cross section is really hard because human skulls are really fragile. It's not that easy that you can just take it and rotate it endlessly to measure it and draw it. So having a software that makes those cross section for us, it's a game changer. Speaking about the collection that is really delicate, on the left side we have some of the examples from Institute of Archaeology in Warsaw. Those are some kettles from bronze kettles from the Roman period found in Poland. Such findings are really, really rare. Also, this collection is destroyed. Is in many cases, in many examples, it's really hard to work with it. It's not that clearly visible on those pictures. Those are actually in really good stage. But as you can see on the top right, it's the neck of this kettle is just gone. On the left side, you can see that on the scanned model of this kettle, we are able to create automatically create the most possible option of the neck, like automatically. So it's reconstruction by the software. You can of course then change it, but if you have a database to choose from, it's easier to make reconstructions as well. On the right side, you have some another example of reconstruction process. It's from the plate from Wisłoujście. As you can see, it's really highly decorated. It's painted totally whole surface. On the top left, you have scanned version, and you can compare that the colors are great, are perfect. This, from the archiving point of view, is great. Also, as you can notice, this plate is in terrible condition. It's just broken, totally broken. Only few pieces are there. A lot of is missing, and none of that was like together. Archaeologists had to glue it together. If any of you ever had to draw anything in such stage, you know it's really hard because it's just not stays together when you touch it. And you have to make some drawings. So when you are making 3D scans, you can make cross sections, you can measure it, you have all documented. On the bottom, you can see two pictures from the virtual reconstruction of this plate, and also from this reconstruction, we can make cross section. You can see the shape of it, the perfect shape. and the lip is perfectly shown. In archaeologists' work, a lot of data, a lot of informations we are taking from how the shape of the lip of the neck looks like. Usually it needs highly trained archaeologists, preferably with knowledge how to draw beautifully, to actually make this kind of documentation. And when you are able to make a cross section automatically, you are sure that none kind of mistake is there. It's just the shape how it is. I was talking about popularization of the national heritage, like inside the country, but also here we have an example of sharing the part of collection between the countries. In this particular case, it was a collection of flint tools from a cave in Georgia. Actually, the excavation in this cave, the head of the excavation was a Polish professor, Professor Krukowski, and the Archaeology Institute from Warsaw on the 100th anniversary contacted the museum in Tbilisi and asked to make it accessible for Polish people to see some part of the collection. It was a huge collection. It is really significant for the period. So the museum in Tbilisi made some 3D scans of part of the collection. You can see on the top picture, this blue one is without any color, but you can see the shape perfectly. Every little detail which is really important when you are working with flints is visible, and on the left side you have a colored one, so it looks really realistic. So the museum in Tbilisi made those scans and they sent it to Poland, to museum in Warsaw, to Archaeology Institute in Warsaw, and we could see this exhibition without having to fly to Georgia to see it. The last example I would like to mention is also really interesting one. It's from Cardinal Wyszyński University of Warsaw, and they have access to a mobile station of 3D scanners. It's actually equipped by SMARTTECH 3D, so they can drive around and if it's necessary make some digitalization, some scans all over. In this case I would like to tell about it actually shows that when you have some interesting artifacts you want to show it, and the interests of it people are interested in, but you are not able to usually. Here we had a skull, the skull called Vampire from Piotrków. The vampire, because of the finds, how it was found, the burial was a burial of a man, and the skeleton was separated from the head. It was decapitated, and the head was buried in some distance from the rest of the body. Also, the skull was pierced through with huge metal nail. This kind of burials are usually connected with some vampirism. That's why it calls the vampire from Piotrków. Actual research, the newest research shows it was not a vampire. It was someone who was. It was a felon probably, but anyways, even the name and this skull with huge nail through makes this particular artifact really interesting. So during any presentation, people want to see it, and it's hard because, well, you cannot drive around with a human skull in your bag, especially when it's pierced through with a nail. So it's really fragile. You can destroy it really easily. So the university made a 3D scan and printed on a 3D printer with color. The print looks it looks identical. The color is there, the texture is there, and with this copy, they can drive around and they can show it during presentations. Of course, there is a lot of other examples and a lot of possibility to use the 3D scans in archaeology. But I think that if you will have any particular question, you can of course ask me. And right now, I would like to go to the live demonstration. It will be more interesting to see how the scanning works live.
Okay, so let's begin how the scanning process look like. So I will start from the single scan. As you see, we have the scanner with the shadeless lamp. So the scanner is projecting the fringes on the object, and on the last frame we get the light from the external lamps to avoid the shades to get the better looking data. And as you see there, we have the raw data, which is the points. And all of the small scratches are visible. It will be more visible on the triangle mesh, which I will show you in a few seconds. So to not waste time, we decided to scan it earlier, just to not look how the object is rotating and then scanning. So here we made two scans. One in the position like right now. The second was made upside down to get also the bottom of the object. So right now, if I will zoom really near, so you can see density of the points and the capturing of this data. It was around 7 minutes. So it's a pretty nice time. And we can see all of the details, all the realistic texture on the object. After that, by clicking, going to the triangles tab, you can just select all the point clouds and create the triangle mesh, which will take around 1 to 2 minutes. As you see right now, we have 32, almost 33 millions of points. So it's a pretty huge amount of data on the small object. And after that, we can see the triangle mesh, which you can see there. It's more than 16 millions of triangles. So everything, every small details, every texture is visible. To show you the really small details, I will just turn off the visibility of our texture to show you that it's not only visible on the texture, but also really small details are visible. So like the thin edges, like the small scratches visible here on our warrior on the painting of the warrior on our vase. Everything is visible. And what we can make with such a data. So at first, for example, we can check the volume of our mesh. So we have our control tab, and by clicking the volume, we have the exact volume of our vase, of our mesh. Then you can check the area of a full mesh, which you can see there in square millimeters. But also, if you want to check only the part of the area, so for example, you want to check the area of the bottom of the object, so you just need to select the triangles and then click area, and we see that it's more than 900 square millimeters. Okay, let's deselect everything. And next, I can show you the cross sections. So we can make the few cross sections just to get the right data. Also, we can export these cross sections. So if you want, you can take this cross section and export it as an IGES file, which you can easily import for the external softwares, even for the CAD softwares, like for example AutoCAD or ArchiCAD. Also, using these cross sections, we can make the dimensioning. So we can check the distance between the points, as you see there. You can check also the distance using the X, Y, or Z axis, or just the 3D distance. You have also the information about the coordinates of the point 1 and point 2. And as it was shown on the video, you can also make the dimensions going on the mesh. So clicking 2 points on the mesh, we can see the partial parameter, which is the green line. I think it could be less visible, but here on my mouse I can show you. And also you can check the total parameter of this cross section. No matter of the shape of this cross section, you can check this value. And also, the newest feature in our software is 3D comparison. Usually, it's useful on the on the quality control, but also we can use it in the archaeology and museology. As I told you, you can scan the vase before the exhibition and after, and then compare it. So I choose our mesh as a reference. It's a little bit changed because I need to have some deviation, and then you can use the 3D compare. Here we are setting the values like the nominal values. So for example, we can put 0.2 millimeters and critical values. And then we can just click compute to get the 3D map of the deviation between our mesh and our point data. So the nominal values are the values between which we will get the green color, and below the minimal value we'll have the blue color, and if the error is bigger than 1 millimeter, we have the red color. As you see there, we have some dents, some defects. So also we can edit our critical values to see it better. So I will just change the value of the critical parameters for the 0.3, and as you see, we have the information that there is too much material because there is a missing area on the mesh. And also we can make some annotation, so some exact deviation in the point which we will pick. Also we can do it on the green area, just to show you that here we have, for example, 6 micron or 17 micron, so it's almost the accuracy of our device which we are using right now. And if you want to share these results, we have 2 options. We can save the project, but it will be the bigger data, and we can also create the report. So we can configure it, put then the author, so for example the operator, so I will put here my name. As a customer, I will put SMARTTECH and the order date. Then we can create the main view. So we can, for example, take the view from with our texture. Then as an error view, we can create the snapshot, and the most important for us will be the annotation view, where we have the information about the exact deviation from our reference model, and we can save it. And let's say the test one, and I will try to open it. Let's just find it. And we have our file test1. And here you have the all of the information, like the author. Also, you have the reference name. You can also give the test model name in the project structure. Then you have our main view, the error view with some information about the RMS error, with the maximal error on plus and minus, also the error of the average error on plus and minus. And after that, we have the snapshot with our annotation, with the additional table, with the name of the annotation and the exact value of our point which we selected. Okay, one more thing which I wanted to show you is how our clients can share the result with you. So I will just create new tab, and just with typing the name of our museum in Warsaw of the history of Polish Jews, we can open the sketchfab of this museum. And here you can see some models which they created. So that's how you can share some results. Yeah, and that's pretty all what I wanted to show you in the live demonstration. If you have right now any questions, please leave it on the chat. We will see it, and we will try to respond to all of your questions. So if you have any questions, just leave it on the chat, and we will see when we will respond it.
Yes, and at the end, I would like to once again thank you to joining the webinar, and also I would like to make some final comments to the 3D scanning with color as an aspect of digitalization, eternal archiving, visualization, and actually digital representation of data, because it's very valuable once we have a pandemic, once we cannot meet, and still we need to maintain our researches as archaeologists. We need to share our results with the audiences from all over the world. So this technology can, of course, accelerate our daily workshop. Once we are scanning artifacts, once we are providing reliable dimensioning analysis. So this is a valuable tool that can not only speed up this process, but it's more precise than the manual methods, which usually as archaeologists we've been using during our excavations. Like I've been on many excavations in Poland, and I never used a 3D scanner, so that's why my work was longer. Yes, once I've been working with ceramics, I've been working with I don't know, some artifacts like brooches, which are very popular in Poland. So and actually the manual methods are all destructive. So we can easily impact the surface of such artifacts, and so our work is not efficient. So once we are using a 3D scanner, we can easily obtain reliable data. We can work more smarter. We don't need to touch the artifacts, yes, and we can obtain a reliable 3D data of such artifacts, yes. And a second thing is that what Peter wanted to show you, but he couldn't find a proper link, is that we can share the results virtually by, for example, a sketchfab. This is starting to be very popular right now, so we can show our exhibits to the wider audience in such a open platforms, when we can just import, upload the data, and we have a color, we have dimensions, we can download such a artifacts. It's very easy, and then it's very smooth. Yes, we don't need to go to the museum to see the such exhibits. And once we are making a researches, we can, for example, making a master degree thesis or bachelor degree thesis or PhDs. We, as archaeologists, we're working with artifacts, and for us, getting to those exhibits are sometimes very difficult because they're in museums like spread it in, I don't know, United Kingdom, United States. We don't have access to them. So that's why using 3D scanners, we can enhance the accessibility. So that's why a lot of archaeologists can use it. And about last thing, what Peter also mentioned, once he was showing the 3D compare function, it's something that I wanted to tell you as a new approach that I met right now in internet, which is called as a reverse archaeology. So right now, the technology, the 3D and digital technologies are getting more popular in the field of archaeology. Also, a reverse engineering technology, which allows us to reconstruct the documentations based on 3D scans, or also we can make a virtual reconstructions of those artifacts. We can provide a reliable conditioning analysis. So what Peter showed you, we can make a 3D compare functions in our software to check if something happened to the exhibit during the time we've been making such a research. Is there any impact? Is there any changes in the surface? Is there any changes in the geometry? Maybe some fragments just disappears, yes, or I don't know, they will just crash during the working on this artifact. So this is very valuable. As archaeologists using manual methods, we are going to we will do not have an eye to that. We will just omit those information they will vanish. They will never be used. And for those cases that also Natalia showed you, in some particular cases, those information were very valuable, and we could get more data. We could reconstruct the history, which is our goal as archaeologists. We are reconstructing the history of ancient civilization, people that live in Poland, people that live in Taiwan, hundreds or thousands of years. This is our goal, and that's why we can make our work easier using the new technology. I think this is the approach that could be added to the archaeology right now. So a short summary of this presentation, but I hope you enjoyed. Of course, I can recommend that if you've got any questions related to such a researches, or you've got some ideas, so please share it with us. We are here to answer. We are here to help you, and I can recommend to have some questions. So we might wait a few minutes for that. Meanwhile, Peter finally found the artifacts from Polin Museum from Warsaw, which is mainly dedicated to history of Polish Jews. So here some chests.
Here we have some chests done by a woman during the World War II. The whole family was hiding in some place, and they were there all the time, so they need to do something because you can see it, for example, for 1 or 2 days, but not for more. So she decided to create this chess and play even without the plate on it. So that's how it looks, and this is one of the visualization with all of the chess. But also here you can see that there's some of the chess for the easier zooming and so on. So that's how it looks. Also, the number of the of the artifact is visible. Also, if you will see there, we have the cross, which means that chess is a black one because they don't have the paint or something like that, so they need to use the some signs on the bottom of it to know which is white and which is black. Okay, let's see. If you have any questions, just please leave it on the chat. If not, you can just contact with us through the email. So also in a few moments, I will once again share you our data, our contact data. So please, if you have any more question, please leave it. If not, it was really big pleasure to meet you, to present for you our newest scanner, to share you our knowledge about scanning in the archaeology. So, okay, I get the information that we have
some questions.
we have some questions. So there is a question if you have any plans for the application of or development of the larger scale sites.
We wish.
We wish, but
We wish that we will have.
so if you
Yeah, friendly speaking, our technology is dedicated to small, medium-sized artifacts, so we can scan effectively ceramic vases, brooches, all kinds of necklaces, jewelry. So we can say small, medium-sized artifacts. And in terms of scanning the whole sites, like excavations, this is another technology of 3D scanning systems that we can recommend to use. But this is like another tool for such excavations. Scanning in open air, I think maybe in future that will be possible with even structural light measurements. Still, the impact of a sunlight is such huge that we cannot obtain the data. So that's why we need to scan in like indoor, like scanning outdoor. It's still difficult for this technology. So yeah, I think maybe it's gonna be planned for the future. I wish that this technology could be used in like open air excavations. Yes.
Yeah. Also, right now, talking about this, you can combine these two technologies. So, for example, you can scan open air using the laser scanner, and after that, scan the small details like I don't know, some artifact on the field using the higher density, the higher resolution of our scanner. So always you can combine this two methods. And the second question,
Yeah, there's Roman. I know.
What is the difference between the 20 megapixels and 18 megapixels? So as Peter told, so the main difference is the time, because scanning using the 24 megapixels is really long, and here it will take around 7 seconds to get the single scan, comparing to more than half a minute of a 24 megapixel. And the second advantage is the possibility of changing the lens of our scanner. So you can change the volume. So if you have the small details like coins and the bigger details, you can use the same scanner with just changing the lens, which is pretty simple with just a taking off the detector and screwing the new. So it's pretty simple. So the possibility of the changing lenses and the time is the most, and also the accuracy is higher using the 18 megapixel.
We have another question from Steven. Yes, Steven, the 24 megapixel have a higher resolution than 18 megapixel. That's true.
Yeah,
this is the advantage of 24, like higher resolution. So we have more details visible.
Yeah, but choosing the smaller volume of the 18 megapixel, you can have the same density as 24 megapixels. It depends what will be better for you. The 18 megapixel is more flexible device.
All right, and the last, I see the question again from Raman. So it depends, like the question from Raman about like if we will lose any data or any details. So it depends on the field of view, as Peter mentioned, that we can have the same amount of data once we are going to use a little bit smaller field of view using an 18 megapixel system. And then like 24 megapixel system will have a little bit higher field of view. So then it will be comparable. Okay. Let's see if we have any other questions. All right, you're welcome, Stephen. Thanks for your question. Thanks that you joined. That's great. All right, any more questions right now? This is a unique chance to we can say to confront with us, with archaeologists like me and Natalia. So
Talk
you
with
can
us directly.
Yes, you
but
can
if
just
you will have any
contact.
other questions later on, you have our email contact, you have our phone numbers, so feel free to contact us anytime if you will have any questions.
How to handle delicate artifacts? This is a good question. This is a good question for sure for archaeologists, museologists. So of course it depends on artifacts. So is it a ceramic vessel? Is it I don't know, like metal or like a jewelry? So I think to put it on the rotary stage table, you always have to be very like gentle with the artifacts. So the thing is that what is the most important advantage of 3D scanner, that using a manual methods of measurement, like I don't know, measurement tape, of caliper, that you need to put it very closely to the artifact, and then you can disturb the surface. Like for example, ceramic vessels, which are they're easy to impact, they're easy to destroy it. So that's why you can put it gentle on the rotary stage table, provide measurements, and then during the measurement there is no contact, there is no impact. So that's why it's very safe.
When you have to draw it, you just take it and you have it in your hand, and then you have to change the position. The touching is a lot, and then with a rotary stage, you just take it, place it, and leave it, and that's all.
Also, you don't need to use the turntable if it's in the place where you have the place around the object. You can just change the position of the scanner. It will be not automate, but you don't need to use to touch the artifact. So I think this is if something is really breakable, so you don't need to touch it. So you can just take the scanner and adjust the scanner position to the object without putting it on the turntable. So it's no problem to just scan in this way, that you are changing the position of the scanner around the artifact.
Yeah, and speaking about the limitations, so once we are working with archaeologists or we are working with museologists, so we are trying to do our best in the field of conservation, but using a conservation approach. We also work closely to people that they're professional in this like conservation and all kinds of like measurements of such artifacts. They're working with artifacts like every day, so that's why we cooperate with them. And if something is fragile, something is perishable, we know about it. So we are trying to do not impact the surface as much as is possible. And then we are trying to scan. Yes. So anything is possible, and anything we will receive from such a persons that are specializing in conservation, then we are getting a lesson from them, and then we are trying to do our best to fit to such a conditions. Yes. Okay, anyway, thank you for the questions. Well, we have another question. What is the largest size object can be scanned? This is a good question. So Peter, maybe
Okay.
explain.
So it depends how many time you have. For example, maybe it's not the museology application, but I was scanning a truck. It is time consuming because on a truck I can put some markers, but on the artifact from the museology I cannot make it. So it will be a lot of manual alignment. But I think the scanning something with the diameter about 2 meters or something like that, it's possible. It depends what object do you have. Just contact us and we will say you if we are able to scan, or we will recommend you some other devices.
Another question related to mobile system. Mobile means like a handheld system, or mobile means that we can move the system effectively through the facility, because these are like two different things. And a second thing, we can also say that mobile system could be a system mounted on the robotic arm. So I think maybe please precise the question what the mobile system is, so we will be able to answer more accurately for this question. Yeah, you're welcome, Gary. And anyway, thank you for your question. Okay, so speaking about the mobile system, yes, it would be possible. Like mobile, like I don't know, we can have like system on the column stand with mobile trolley, adjustable trolley, so you can move the system effectively through the facility. So this is how I understand mobility. But any form of like handheld scanners, we don't have already in our offer. I don't know, maybe in future we'll add such a system, but we don't have. And also, as you might know, as you joined previous webinar, we have a system solution on robotic arm, but this is mainly dedicated to like industrial applications. So
yeah, also as you see on the camera, we have the Micron 18 megapixels. Also we have the smaller devices, which is a universe scanner. It's a scanner of the size that you can take as a hand luggage to the airplane. So also, if you are talking about the size, that this scanner is too big, so we have the smaller ones with the resolution 2.5 or 10 megapixels. It's also a really nice device. So it depends what is your need. You can just contact us and we will tell you everything.
Anyway, thank you for questions. We really appreciate that we could answer and help you. As Peter told, please contact us at any time if you will have any more questions or specific questions related to your ideas or your possible workflows or projects. We are going to be glad to share our experience. So once again, thank you for joining the webinar, and I hope we are going to meet again because we are going to plan the next webinars in next months. And still, I believe we will be able to meet face to face. Yes, so still we believe that the COVID-19 situation will get only better and better. So this will allow us to, I don't know, travel, meet during the conferences. This is what we are looking forward. So once again, thank you and goodbye.
Goodbye. Thank you.
Thank you very much.